occupies all the sites in a competitive manner. So, say one person in this room was naltrexone and all the other were morphine, morphine would win. If it's 50-50, there will be no effect at all. So it's completely competitive, and it can replace, morphine can come in and push naltrexone out. On top of that, there are further complications. If all the receptor sites are occupied by a high dose of naltrexone, the body sees this and says, hang on, everything's blocked, we have to make more receptors, and it actually starts to make its own receptors, and not in equal numbers. So this may explain, it certainly, I feel, completely explains why high doses of naltrexone do not work the same way as low doses. An interesting point that I would like to ask is why other drugs of a similar nature haven't been used as much. Naloxone being the obvious example, it's another very simple, soluble, stable drug. Naltrexone is stable, it is soluble, and it's a very fast-acting drug. That's key, because you don't want it to linger around and cause eternal blockade of the receptors, because that effect of the new receptors being made will come about. It's expiring stability and formulations. I want to look at that because there are a lot of different formulations being proposed and being talked about. A lot of homemade preparations. The good news is most of them are relatively stable. Naltrexone is a small molecule, and it's relatively small when I speak in terms of proteins and insulin being massive molecules. Naltrexone is complicated but not very, and it's both fat and water soluble, which is a key property, meaning it can be used in transdermal preparations, which not every drug can be. Transdermal meaning you put on a sample of the drug on the skin in the right vehicle and it will pass into the bloodstream. Quite a lot of drugs will do that. Some we don't want to, and many we do. Obviously there are better or worse carriers, and Skip is a bit of an expert when it comes to the transdermal and like the preparation that will go through the skin. It's a very new science in Ireland. QM, I don't know if they've got into that yet, so it'd be interesting to ask later, ask David or Akram if they do transdermal preparations yet, but certainly there are cases where people can't swallow or are unable to swallow, and drugs may be of a benefit in a carrier if it goes through the skin. Naltrexone is stable up to 90 days in water. It actually has been tested 70 degrees centigrade in water and has been stable for up to 30 days. The maximum pharmaceutical, legally the maximum pharmaceutical of a hand-prepared product will be 30 days anyway. So it's certainly stable for up to 30 days as long as it's stored in the dark. So if people are concocting something at home or putting tablets in water, my advice would be keep it in the dark and keep it in the fridge. In dry powder, the stability is almost indefinite. When I say indefinite, I'm not using a loose term there. Really, in the industry term, that means in 5 years, 95% of the drug is still patent. And that is, from what I read, that is the stability of naltrexone powder. It is, however, hygroscopic, which means it attracts water and then dissolves in it. It's a bit like me on Friday night, I attract Guinness and dissolve in it. I had a link here for, I don't know if it would work, but it's, I wanted to show you the molecule. Let's see if it'll work. No, I didn't. But the molecule is so similar to morphine, it's incredible. So we'll move on. So the forms of naltrexone being used, the most commonly ones, are number one, liquid. It dissolves in water. If you blog a lot of the websites, and God knows there are a huge number of websites now, a lot of people are getting the tablets and then the 50 milligram tablets in a relatively fast release form and dissolving in water. They're basically cutting their own, mainly because of economics. The drug is so expensive to buy handmade, except for a few exceptions like Skip who provide it in America at incredible prices. We don't have the market or the numbers yet. I think he said he had 8,700 doctors. I have about the same number, minus 8,692. More or less the same, really, in very hard terms. Tablets, people crush the proprietary tablets and dissolve them in water. There's nothing wrong with it if you know what to do. And for 30 days, you're getting around the release rate of the product because it will dissolve into the water. So it's perfectly okay. One thing I would ask people, Would you drink a glass of water that you've left in the fridge for 30 days? I wouldn't. You know, I'd be a wee bit concerned about bacterial growth and what might be in it at that stage. So, as a pharmacist, I would say if I'm going to make a liquid, I would like to make it in a form that's slightly better at preserving itself, something containing ascorbic acid, for example, to stop it oxidizing, and some to prevent bacterial growth. Most people use glycol or something, and glycols are not the safest compounds in the world either. So, I don't particularly encourage or make up a lot of liquid forms of it. Nonetheless, I do feel it's a viable alternative and an economic alternative. And Stephen Dixon from Dixon's Pharmacy in Scotland has a formula of his own, which he developed from a local hospital, and it seems to be a very stable and a very safe liquid formulation, and also very cheap. So kudos to Stephen. He's done a lot of work on this as well, in conjunction with Dr. Gil Hooley, who we hope will be here later today. The capsules extemporaneously diluted. Extemporaneous basically means thrown in a bucket and stirred. I know that's what pharmacists do, but they like big words to make it sound more scientific. Well, we don't like them, but our regulators do. It's diluted with a filler. The important thing there is that the filler dissolves very quickly and lets the drug go. You don't want something that's going to bind the drug and chemically stop it from going into your bloodstream, and you don't want something that slows down the dissolution of the powder itself. Calcium has a habit. Calcium carbonate you'll often see mentioned in a negative way. Chalk has a habit of basically chalking up again. You know, even if you crush it into a powder and put it into a capsule or a bottle, it eventually cakes up again, and it cakes up relatively quickly. That makes the powder slow to dissolve, and it seems to affect the dissolution rate of the drug, and you get a longer period of time before it gets to the bloodstream. Now that time is quite critical because naltrexone peaks in about an hour. It takes 12 hours to wear off. It's very important that it does wear off for reasons we'll explain later. The transdermal gel I already mentioned. Emu oil, and that's not an extract of liquidized emu, just like baby oil is not an extract of liquidized babies. Emu oil or a PLO is now another proprietary gel used a lot as a carrier for transdermal drugs. LDN, we want to look at the effects in the body. We want to look at what raised beta-endorphin levels would do for you, other than make you feel good. Is that all it's doing? These are the questions, the hard questions that need to be asked. Do I just feel better? Has it done nothing else other than make me feel better? And as a pragmatist, I would say, so what? If you feel better and you feel stronger, so what? You know, it hasn't cost you a fortune, and you're certainly not going to do a lot of harm with it. Whereas some of the other clinical trials I've looked at of other medicines that are licensed or at least used in the treatment of MS, for example, I would say they have equal effect to naltrexone, but an awful lot less baggage, or an awful lot more baggage with them, as in side effects and risks of bodily damage. The T cells I put a question mark after because there's great debate about which T cells are involved in inflammation, which ones are involved in attacking the body itself, autoimmunity in other words, and which ones are involved in hypersensitivity or allergy. All of these things are important. We basically want to promote helper T cells, and we don't want to encourage the T cells that destroy or that are associated with inflammation. Again, this is important because how could a drug that reduces growth in cancers also help growth in recovering myelin? And that's another question that needs to be asked. There are answers starting to appear. I certainly found a few of them last weekend. The proposed effect of naltrexone on one's immunity is important, just as the proposed effect on one's immunity of all the other anti-MS drugs or MS treating drugs and the new MS drugs that are coming along. Immunity is where they're all focusing at the moment. Almost all the drugs, there's a new one out this week called Gilenya, fingolimod. It's acting on immunity as well. They all act in different ways. Some of them stop immunity developing, some stop the immune cells from going into the brain at all. Others stop certain types of immune cells from acting in certain places. It's getting there. I honestly believe the conventional treatment of multiple sclerosis in particular is getting there. Other illnesses were still a long way off in neuromuscular disorders. I think naltrexone may well unlock a few of the secrets of how immunity works, particularly in Zayvon.